GCSE Physics Boosters, Newton's first law. There are three, first, second and third law. This video is about Newton's first law. Now, 1687, this book, Principia, and it contains Newton's three laws of motion, amongst other things. And they are mega important in physics and engineering. Basically, without these, there wouldn't have been an industrial revolution. Yeah, they're incredibly important. Newton's three laws of motion, and he didn't come up with them all by himself. There were people before him. There was Johannes Kepler, there was Galileo, and they kind of were halfway with this stuff. But Newton wrote the book, literally. Newton was a very clever bloke. He was a scientist, he was a mathematician, and he came up with his three laws of motion. And the first law, well, before I say what the first law is, consider this. Now, if you push a toy car, then it's going to slow down and stop. And the question is, why does it slow down and stop? And because of friction. Friction always opposes motion. Friction tries to stop things moving. It tries to slow things down. It opposes motion. And friction will slow down the car and it will stop. If there was less friction, okay, so if you chuck a curling stone across ice, then it travels a lot further. Now, why? Because the friction force is a lot smaller, so it travels much further. Okay, what if there was no friction? What would the object do? Well, consider this astronaut in deep space, nowhere near any planets or stars or anything, and if he chucked his spanner, that spanner would keep moving in a straight line with the same velocity forever, because there's no friction slowing it down. And that is basically what Newton's first law is. If there's no forces acting on an object, or if there's no resultant force acting on an object, then if it has a velocity, its velocity isn't going to change. Okay, Newton's first law. Basically, if the resultant force is zero, then if something's not moving, it'll stay not moving. If something has a velocity, then its velocity will not change. So it'll continue to move at the same speed in the same direction. Its velocity will be constant. Now, these objects are stationary. There is no resultant force acting on them. Okay, there are forces acting on them, but there's no resultant force, so they will stay stationary. Now, these objects are moving, but their velocity is constant. So that means that there is no resultant force acting on them. Okay, they're in what we call a dynamic equilibrium. You've got the car traveling at a constant velocity, all kinds of forces acting on it. There's this person in the middle is traveling at terminal velocity. And so air resistance and weight are equal and opposite. And then the skier going down the slope, again, there's loads of forces acting, but there is no resultant force, so their velocity doesn't change. So a resultant force is needed to make something move or to change the way it's moving. Now, there's a word you should know called inertia. And I'm not a big fan of it because people get it muddled up with a few things. It's basically the tendency of an object to stay at rest or at a constant velocity is its inertia. And there's a typical teenager doesn't want to get out of bed on the morning. They've got a lot of inertia. It's basically if something has a lot of mass, then it's hard to get it moving, or if it is moving, it's hard to change the way it's moving. So inertia and mass are kind of the same thing. Now let's finish with something different. Here's a car going round a bend at a constant speed. So its speed isn't changing, But is its velocity changing? Well, the velocity isn't constant. Why not? Because velocity is a vector. And because the direction that the car is moving in is changing, that means its velocity is changing. So from Newton's first law, there must be a force acting on it, a resultant force acting on it. And what is that resultant force? What force is making it go round in a circle? And here's a clue. What would happen if the road was icy or covered in oil? Okay, well, I'll tell you what would happen. The car would go off at a tangent and end up in a hedge because there wouldn't be enough friction. So it's friction in this particular case which pulls it round the circle. Yeah, a resultant force might change the direction that an object is moving in without changing its speed.